The third of Hilbert's 23 big problems was to show whether polyhedra of equal volumes were always scissor congruent or not. Wow, what does that mean? Well, it had been known for almost 100 years that polygons, that is 2D shapes with straight sides of equal area, are scissor congruent. And that just means that I could take some scissors and make a finite number of cuts to this and rearrange the resulting shapes and make this shape as long as it's of equal area. Indeed, I could make some cuts to make any shape that I like as long as it's of equal area to this. Is the same thing true in 3 dimensions? Could I cut up this and rearrange the pieces to make this as long as they're of equal volume? Well, the answer is no. And this was shown by Max Dane, and he did it by identifying something now called the Dane invariant. And this is where we might all get a little bit lost, but the Dane invariant is the tensor product of the length of edges multiplied by the angle between the faces at those edges, all summed up. And here's the key thing. Once you've got that sum, the resulting angle is taken modulo rational multiples of pi. So if your resulting angle is a rational multiple of pi, the whole thing becomes 0. And that's the case of shapes like this, because you can see all of the faces meet at pi over 2. That's a rational multiple of pi. So if I add up all the faces, all those angles, I've got a rational multiple of pi, and that just drops out. It becomes 0. The Dane invariant of this is 0. However I cut this up, the sum of the Dane invariants of the smaller pieces of this book would still be 0. And you can kind of see that because I could cut at an angle like this, but the sum of the angle there and on the other side would still be pi. So in the end, the sum of these angles would become 0 and the whole thing, the whole Dane invariant would be 0. Not so for a shape like this, where there are irrational angles involved. Now let's step back a bit. What does this mean? Well, it means that you can't simply analogize from 2 dimensions to 3 dimensions. Things that you might not expect start to happen. And the other thing is, this process of looking for invariants is so key to maths and physics. You can think of it as trying to find the soul of something. What doesn't change when you break it down? The volume is important, but the Dane invariant is another thing, that constant.